Hi everyone, welcome back to the channel. In this video, we are going to understand one of the most important and beginner-friendly sorting algorithm, that is insertion sort. If you are preparing for coding interviews or learning DSA for the very first time, the algorithm is a kind of must-know. So let's understand first what is insertion sort. So insertion sort is a kind of sorting technology that we do it on the comparison basis. So how we play the cards, right? When we play the cards, how we sort it? What we do usually, we take one card at a time and place it in its correct position among the cards which are already sorted. So that's what exactly the insertion sort does also. So the core idea of the insertion sort is kind of what we will do first. We will divide the complete array into two parts, which is the one is sorted part, another will be unsorted part. So we are not sure which part is sorted and which part is unsorted, right? So the first element we will take as a sorted, then the another element, whatever the remaining elements are there, so those will be kind of unsorted. So sorted parts we are considering it because there will be only one element, right? So that's kind of sorted only. So then we will pick one element from the unsorted elements and place it in the correct position among the sorted elements. So that's the core idea of the insertion sort. So how it works, if we see, so we will pick it, then we'll compare it among the sorted elements, then we will shift the elements, then we'll insert it in the correct position. So those process will repeat in the each step. So if we come to the characteristics of this insertion sort, so it is comparison based algorithm, as every time we shift and do insert, so we had to do the comparison first, right? Then it is also in place sorting technique and efficient for the smaller data set. So every time if you are doing shifting and inserting and all this, right? So it's usually we do when the data set is nearly sorted or the data set is quite small. Let's take an example to understand it better. Here I have taken 8, 3, 5, 2, 9. This is my array of elements. Okay, so first thing what we have to do, we have to convert this array of element into two parts. One will be sorted part, then another part will be unsorted part, but we are not sure which part is sorted and which part is unsorted, right? So in this case what we will do, we'll consider 8 as the one element as a sorted part. As it's have only one element, so definitely it's sorted, right? And the other elements will consider it as a unsorted part. So the next thing what we have to do in the each iteration, we will take one element from the unsorted part, then we'll compare it in the sorted parts and we'll place it in the correct position. Okay, so in the pass one, if I do, here is the pass one. What element I have to take? I have to take 3, the first element from the unsorted part, right? So 3 will be compared to 8. 3 is less than 8. So what we need to do? We need to shift 8 towards right. So now my array will look like something like this. 9, 2, 5. Now 8 is shifted, right? So 8 will be here. And here the position is still empty as there is no element in the left of this array. So what we will do, we'll simply place it 3. If there will be other elements, then we will compare it. Now in the pass 2, the sorted array keeps growing, right? Now the sorted array becomes 3, 8 and the unsorted array becomes 5, 2, 9. So our key element, what element we will take? We will take 5, right? So 5 will be compared to 8. 5 is less than 8. So what we will do? We'll shift 8 towards right. Then the array will look like something 9, 2, 8, this position will be still be empty because we are not sure which element should be kept here, right? So 5 will be compared to 3 again. 5 will be compared to 3. So what is happening? The 5 is not less than 3, right? 3 is less than 5. So no need to do shifting. So we'll place over here 5. 3 will be as it is in the place. Okay. So now in the past 3, what is our array of elements? 3, 5, 8, 2, 9. Now this is our sorted part. This is our unsorted part. Again, our key element would be here 2. 2 is less than 8. So we will shift 8. So the array will look like something. 2, 8 will be here. Now 2 is again less than 5. So what we will do? Shift 5. Now array will look like something 5, 8, 9. Then 2 is less than 3 as well. Then what we have to do? We have to similarly shift 3. Then 3, 5, 8, 9. There is no more element present. So simply we will insert 2 in the most position. Okay. So in the pass 4, our elements will be something like this. 3, 5, 8. So in the pass 4, our element would look like something like this. 2, 3, 5, 8, 9. Now if you see 2, 3, 5, 8, 9, this becomes our sorted part. This becomes our sorted part, sorry. This becomes our sorted part and this 9 becomes unsorted part, right? So we'll compare similarly way. 9 is greater than 8, so no shifting will happen. 9 is greater than 5, so no shifting will happen. And 9 is greater than 3, so no shifting will happen. Again, 9 is greater than 2, so no shifting will happen. So the array will be as it is, 2, 3, 5, 8, 9. So this is our final sorted array. So this is basically the theory explanation of the insertion sort. But now we will do the Java implementation in code, what it does. Okay. So what we need one array to iterate, right? So one element, this is what we'll do. We'll convert this to part. One element, one array we will run from 3, 5 to 9. So the array will be start like something 1 to n minus 1. Then what we will do? We'll take one key element to store our 3, then 5, then 2, then 9 to insert that element, right? The key element. Then we need one element like j to compare. This is the unsorted array, right? So we need again one while loop. So this is all what we have to do, and whatever the operation we have to do, we have to do shift then insert. We'll take one element, we'll shift it, then we'll insert it. So let's have a look on the Java implementation of this. So if you could see my screen, that you can see that I have created a class named as Insertion Sort. So then we need one main class, right? Let's bring the main class. Then again we need one array of elements which will contain some element, right? So we'll keep the same element. I'll keep the name as array itself only. Then we'll print 8, 3, 5, 2, then 9. Then what I will do next, I'll print the elements before sorting, then I'll print the elements after sorting so that we can make the differences easily. Now let's do the same thing. System.out.print. Then now we'll do before sorting. Then for printing the array of elements, we need one for loop, right? For it is a num I, then print. We'll print the elements. We'll keep one space in between each elements to make it more clear. This is before sorting. The same thing we'll do for after sorting. Okay. I'll keep one line of space over here also, so that after sorting will get printed in the next line. Okay. If we'll run this insertion sort class right now, we'll see no differences because we have not provided any sorting logic over here. So before jumping into the logic, so whatever algorithm logic we understood, that insertion sort uses two loops. One outer loop for selecting each element and the inner loop which shift the larger element to create space for the insertion sort, right? So the outer loop we need for integer I equal to 1. Why 1? As I told that as part of this sorting algorithm, what we have done, we have converted that particular array of elements into two parts, right? One will be sorted subarray, another will be unsorted subarray. So we don't know which part will be sorted, right? So we assume the zeroth element as a sorted subarray, and the remaining element as a unsorted subarray. That's why we will start the loop from the ith, from the 1th element. Then I will continue until the array of length will increment it one by one. Okay. So then what we'll do, we'll take one key element which should be array of I. So after this we need another variable which will what it will do, it will check against the sorted subarray that in which element should be shifted and where to insert the exact key over there. So for that we need the jth also, and this is our while loop which will be the inner loop for shifting the larger elements and to create space for the insertion sort, right? So it will continue until j is not equal to j is greater than equal to 0, and there will be another condition that array of j is greater than the key. So next, if this is happening, then what we will do, we will shift the elements towards right, then array of j. After shifting, what we will do, we'll check the next element. So for that we need to decrement j because we are moving from right to left, right? So when all the elements are done, then we will find out where the key should be placed. Array of j plus 1 is equal to key. So that's all we have to do. Now if I'll run this, you could see that there is something is missing. Okay, I might have missed something. Okay, sorry. Here I have printed it. Array.length. So this mistake, to avoid this one, what we could do, that Control C will create one variable int n equal to array.length. Now we will use the same variable over here. Okay. Now if you could see that, our array is sorted. So for coming to the time complexity of the insertion sort, it is same as the bubble sort. In the best case, it will be O of n, and in average and worst case, it will be again O of n square. And it works best when the array is nearly sorted. And if I come to when it is useful, mostly it is used when the data sets, whatever we have, it is smaller in quantity. So that's when the insertion sort usually used. So that's all for the insertion sort.